let's talk about cookies. Cookies? Weird. We were supposed to talk about math. But we're going to talk about cookies. Cookies and ratio, of course. Come on. Just ratio is too boring, man. Let's let's talk about cookies as well. So let's color our problem of ratio with cookies. It's going to be much more fun, and I hope you have as much fun as I had solving this problem and creating. And to be honest, I tried to make as much complicated this problem as I could make. So welcome on board. Now, this is the third ratio problem of this series. It's the third one because I decided to make the first two to prepare you to do this third one. So if you haven't watched ratio 1 and ratio 2 on the cards above, also at the end of the video, also on the description below, please, I fully advise you to do so. Go back to ratio 1 video, go back to ratio 2 video on my channel, only then go to this one. Can you follow this video either way? Yeah, of course you can, but you're going to understand much better, you're going to enjoy much more if you just follow this one. I'm not going to describe passages that were fully described on the past videos. I won't. That's why I made them. So I advise you, first go to ratio 1, ratio 2. Now, what about ratio 1? I'm going to give a brief description, far from being enough to follow this video, but just to get a glimpse of what those two first videos are. Ratio 1 deals about ratio problem where the total does not change. So we have two people, like this people is giving 5 books to that person is giving 5 books to that, just exchanging books. The total does not change, it is one approach. The second video is where the total does change. So remember, when the total did not change, just exchanging, but the system is closed, it's closed. Nothing leaves, nothing gets in. Now, on the second type of this problem, ratio 2 problem, deals about where the total is changing. So now our system is open. So something is going to come in. So we're going to add something into our system from outside, and maybe something from our system is going to be given away. So our system is losing parts and also receiving parts. So the total is changing throughout the process. Now, how can you solve this problem? Actually, we can solve it. So because of this, we're going to create, because we don't know how to solve it. In math, when you don't know how to do something, we will create something simpler where we can search. We create something simpler where we can solve, then we go back to the original problem. We're going to do the same. When the total is changing, nothing is constant, we have to create a problem, a parallel problem, where something is constant. So we're going to multiply this problem by some constants, plural, or maybe constant, singular, get a parallel problem where something is going to be forced to be the same. Now, when something is the same, we go back to ratio 1 problem, you see? We solve this one. How can you go back? Well, if we multiply this by 5, if we divide by 5, we reach to the original problem. That's how we're going to solve it. But this problem, it demands a little bit further than this. Why? Because as you can see that this problem here, can you see that this problem is a little bit long? So, for that, we need to be very focused. We have to build a very strong table, and we have to know what we're doing. That's why I told you, if you haven't watched, especially ratio 2 problem of this series, please consider going there. Pause the video, go there, and then return. Now, I'm going to create a table. I'm going to create 4 tables. First, I'm going to prepare the first table with this text. Then I'm going to make the text disappear, and we're going to the full board, blackboard, and then we're going to solve it. Now, let me just advise you. We're talking about 2 sisters, and those sisters, they are preparing cookies. But one sister knows how to prepare the dark chocolate cookie. Only that. So one sister is going to be in charge of preparing the dark chocolate cookie. She's going to prepare some, and she's going to give parts to the other sister. The other sister doesn't know how to cook chocolate cookies, dark chocolate cookies, but she knows how to make nut chocolate cookies. So the other sister is going to make the nut cookies. She's going to stay with a few and going to give the other part to the other sister. So you see, cool. Let's go. So at first I'm going to write the problem. So this is going to be the problem. So this is going to be our problem. I'm just going to copy the numbers, which is a system, we can solve it, but we have to start somewhere. Now we have Chloe. So let's try reading the problem here. So two sisters, Chloe and Zoe. So we have Chloe, and Zoe. So Chloe is going to make the dark chocolates, and Zoe is going to make the nut cookies. Now Chloe is going to make the dark, but it's going to give a few to Zoe as well. So Zoe is also going to make the dark. Zoe is going to make the nut cookies, but she's also going to give a few to her sister. So this is going to be the start of our table. Now let's continue reading. So here. So now Chloe and Zoe are preparing cookies. Chloe makes the dark chocolate cookie and gives 3/4 to Zoe. So now Chloe is going to make some cookies. 3/4 that is going to Zoe. So it's safe to say that Chloe is going to have one part, and the 3 other parts she's going to give to Zoe. Agree? Now let's continue reading. Here. Now, next one. So now Zoe makes the nut cookies, and Zoe is going to give 2/3 of that to Chloe. Now again, this is Zoe. This is Zoe is making the nut cookies. She's going to give 2/3 to her sister. So let's say this is 2B, and one part, B, is going to stay with her. Agree? At the end we have 3 parts. 2/3 goes to her sister, 1/3 to her. This is the beginning. This is how they begin everything. Now, continuing, we are... Okay, now here, this line. So Chloe gives 3 dark cookies to her mom. So Chloe is going to give 3 dark cookies to her mom and 10 nut cookies to her classmates. So again, Chloe is going to give 3 minus 3, subtraction of the dark chocolates to her mom, and 10 nut cookies to classmates. So minus 10. And just read the problem. Now let's continue. Here. Okay, now... Okay, here. We are here now. Now Zoe noticed, let's talk about Zoe now. Zoe noticed she already had 6 dark chocolate cookies from the day before. An extra 6. So 6 is coming into the system now. Because she noticed that she not only had the 3A dark cookies that her sister gave to her, but she discovered she had a +6 from the day before. Okay, from the day before, enjoy them with the ones Chloe just made. Now, here. But, since Zoe loves nut cookies, Zoe is going to eat 2 of those nut cookies. So, the nut cookies, she started with B, but she ate 2. Okay, now, at the end, Chloe's ratio of dark to nut cookies is 5:4. We finally have this ratio, which is 5:4. Now Zoe ended up having 6 times as much dark as nut cookies. So the ratio is going to be 6:1 here. And I want to know at the end, look, the final question, how many more cookies did Chloe prepare than Zoe? So how much more? Because Chloe prepared 4A, Zoe prepared 3B. I want to know what is 4A minus 3B. I want to know this. We have to solve everything to get this done. So now, like I told you, I'm going to disappear with the origin of the problem because we don't need it anymore. Everything we need is on this table. That's why I love to make tables, because of this. So this is our problem. Now I'm going to create our model. So this is going to be our model. Why do I call model and not problem? Because now I'm going to change those ratios accordingly. So I'm going to make this become the same ratio. It's going to be 20 to 20. And this is going to be the same. It's going to be 6 to 6. I need to do this to solve. I need to create something equal. We're going to see why. So I can equate things. And because I will no longer work with those initial ratios, I cannot call that this is my problem. This is the parallel problem. I'm going to solve that, and then once I solve this, I go back and get the true values here. So our model. So this is our parallel problem. Now we have Chloe, we have Zoe, we have the dark, we have the nuts, we have the dark, we have the nuts. So I'm going to multiply this column by 4, so I can get a 20, and I'm going to multiply this 4 by 5. I want to get the same number here. So 20, 20, 6, 6. I multiply 5 by 4, I get 20. 4 by 5, I get 20. Of course, I have to multiply every number on the column, so I don't make any mistakes. In here, I have to transform everybody for Chloe's nut cookies, multiply by 5. And here, clearly, multiply by 6. Everything is explained on the second video of this series. Now, Chloe is going to, this column is going to be multiplied by 4. So it's going to be 4a. This is going to be minus 12. This is going to be 20. This is also going to be 20. Of course, it must be, because I'm making everything to have the same number. So 2b times 5, 10b. Minus 50. Now for Zoe, I'm not going to change this column because there was no need. You see, it did not multiply by anything. This column is going to be multiplied by 6. So Zoe is going to start with now 6b nut cookies. She's going to lose minus 12. You see, minus 2 times 6, now it's minus 12. And the ratio is going to be 6 to 6. Reading this table, please, it is important. So Chloe, under this scenario, is starting with 4a cookies of dark chocolate. She's going to lose 12, and the ratio is going to be 1 to 1 at the end. Now, about her nut cookies. She's going to start with 10b cookies. She's going to lose 50. She's going to end up with 20. Actually, not 20 cookies. She's going to end up with a ratio 1 to 1. If those were 20 cookies, then I would, to know 10b, I would just need to add 20 plus 50, 70, 20 plus 12, 32, 6 plus 6, 12, 6 minus 6, right? Because something plus 6 is 6. So, can you see how it doesn't make sense? Look, 0 plus 6 is 6. Clearly, this is not 0. So clearly, this 6 is not the number of cookies. It is just a ratio. This number, you have to understand this. This number is the number of cookies. This number is the number of cookies. This number is just a ratio. Could be 20, could be 40, 60. This could be 6, 12, 18, 54, whatever. A multiple of that. We're going to see in a short moment. Now, this is what we created, this table. Now, you do realize that I created a situation where the ratio is 1 to 1. Agree? 1 to 1 and 1 to 1. So whenever Chloe had a dark chocolate, 4a minus 12 is the same as 10b minus 50. At the end, I told you, they have the same amount of dark to nut cookies, both of them. So let's do it. So she started with 4a, then minus 12 equals to 10b minus 50. we can simplify this. 2a minus 6 equals 5b minus 25. This is for Chloe. Now let's go for Zoe. For Zoe, we have 3a plus 6 equals to 6b minus 12. Divided by 3, so a plus 2 equals 2b minus 4. So realize that now we have two variables and two equations. This is the first equation. This is the second equation. You see? Chloe gave us two variables and one equation. Zoe gave us the same two variables and another equation. Now we can solve. I'm going to make equation 1 minus twice equation 2 to get rid of this a. So 2a minus 2a, gone. Minus 6 minus 4 minus 10. 5b minus 4b. b minus 25 plus 8 minus 17. Therefore, b equals to 7. If b is 7, 2 times 7, 14, minus 4, 10, minus 2, 8. So that means that a equals to 8. Now, time to stop. Please, stop. Think. You are going to say this, not me. Stay with me. A is 8, B is 7. All I have to do is to put A, 8, and B 7. By the tone of my voice, you should be suspicious. So the answer is no. Why? Now let me ask you, is this solution for this system or for that system? Second, are those two systems the same or are they different? Because if they are the same, I can use the solution here. If those systems are different, I cannot. Those are things you have to think while you are solving a math equation, a math problem. You have to know exactly every time of the moment of the problem where you are. Remember, on this situation is a situation where both they have the same amount of dark and nut cookies at the end. That's not our problem, is it? Different amounts. So clearly, this is a solution of that system, not that. I'm not solving the initial problem. I'm solving the model. Be careful. Be careful about this. So let's update our model. So I'm going to now update our model. So it's going to be the model updated. So we have Chloe, we have Zoe, dark, nuts, dark, nuts. Now for A, 4 times 8, 32. Minus 12, just minus 12. Now, 32 minus 12 is 20. It's a huge coincidence. This 20 is like this. It could be 40, or it could be 60. Okay, it could be 200. It's a huge coincidence. You're going to see that for Zoe, it's not going to work. Because remember, this is ratio, 20 to 20. I never said those were cookies. That is cookie, that is cookie. That is just a ratio. But at the end, it ended up to be the number of cookies. Because it was 1 to 1. So not 1 to 1 here. Because the constant that I had to multiply was just 1 for a huge coincidence. 32 cookies minus 12, 20 cookies. What about nut cookies? 10b. 70. So Chloe started with 70 nut cookies. She lost 50. She ended up with 20. Now for Zoe, we're going to see that it's not just copy 6 here, 6 here, 6 here. It's not going to work. This is just a ratio, 1 to 1. Now let's see about Zoe. I could make 1 to 1. If you wanted to, no problems. So Zoe, 3a. 3 times 8, 24. So Zoe started with 24 cookies here, plus 6. You see, she's going to end up with 30. I told you, 30 cookies. The ratio is 1 to 1. 30 cookies. Now, nuts. 6b. 6 times 7, 42. She's going to lose 12. Beautiful. I told you, 20 to 20 cookies, 30 to 30 cookies. Now, this is not our problem. This is the parallel problem we created. We have to go back into the initial problem. How? Well, what happened when we turn this into a parallel problem? As soon as we multiply this column by 4, this column by 5, and this column by 6. So we have to undo this. So let's go back to our problem. So these are going to be our problem. Finally, we are returning to our problem. Now this is our problem. Let's return it. So let's see. Everything now is cookies. I just have to divide by some constants, the same one I multiplied, so everything is set. So let's go for Zoe, Chloe, and Zoe. Now this is going to be dark, nuts, dark, nuts. Beautiful. Now what happened? How can I go back to the initial problem? I'm talking about this column. This column were multiplied by 4. So I have to divide this column now. I don't think, I hope this works. I think so. I mean, I hope that the arrows doesn't make any more confused. So I have to divide this by 5. If I divide this by 5, I'm going to get the true values of our problem. Oh, by 4, sorry. Oh, come on, man. So many numbers here. Anyone get confused? Divide by 4, isn't it? If I multiply by 4, I have to divide by 4. Undo what I did at the beginning. So 32 by 4. Finally, 8 cookies. Chloe started with 8 cookies of dark chocolate. 12 by 4, 3. 20 by 4, 5. Minus, of course. So, this is true. Chloe started with 8 dark cookies. She gave 3, and 5 is how much she's left. Now, what about for Chloe? Chloe did not chocolate. I multiply by 5, so I have to divide this column. This one I have to divide now by 5. Undo what I did here. So 70 by 5 is 14, isn't it? 50, 20, yes, this is 14. Minus 50 by 5 is minus 10. 20 by 5 is 4. Finally, oof, same ratio. Of course, I had to go back to my initial ratio or something would be wrong. Now, let's talk about Zoe. Well, nothing happened here, okay? I never changed this column, so for Zoe is the same. So it's going to be 24 plus 6 and 30. Now, this column multiplied by 6, so I have to divide by 6. Let's see. 42 by 6 is 7. Minus 12 by 6 is minus 2. 5. Well, wrong? Is it wrong? Did I make any mistake? 30 to 5 and it was 6 to 1. We're talking about ratios. Is it wrong? No. Yes? I don't know, you tell me. I'm asking you. No, I know the answer. Think. Come on, wait. Is it wrong? Is it right? Is it the same? You tell me, I asked it first. My channel is ARISTOTHINK. We have to think. Of course, you had the answer a long time ago. Sorry. The ratio is 6 to 1. It is still 6 to 1, isn't it? Divide by 5. So, I said I could have 1 to 1 here, doesn't matter. This is just a ratio. But now is the number of cookies. 30 cookies to 5 cookies. It's the same as 6 to 1. So it is okay. Now, so this is our problem. Our problem is this one. You see? This is our problem. Those numbers are worth gold. We made everything to get to this column. And now they're asking our final. So let's go to the answer. Chloe, how many cookies did Chloe eat? She made all the dark chocolates, agree? The dark cookies. So 24 plus 8. So Chloe, I want to know Chloe minus Zoe. Don't worry. This is what I want to know. So Chloe made 8 plus 24. She made all the dark chocolate cookies. Minus, what about Zoe? She did all the nut cookies. She made 21 cookies. So 14 plus 7. So finally, so this is what, 32, isn't it? Minus what, 21? Usually it is. Now 32 minus 21, usually it is 11. Cookies. So this is the answer. 11 cookies. 11 cookies and a lot of fun. So this is the problem. So if you enjoy the problem, and I really think, I hope you have, it was a pleasure to be with you on those 20, almost 30 minutes. So we started with a problem we did not know how to solve. Everything was changing, and to make it worse, we had no idea about this ratio. No idea. We're blind. So we did not have information about this ratio. We know that A and 3A to B and B, but we have no idea what is the ratio between A and to B. So it's like someone gave us a problem and forgot to give us the ratio. But that is why we have another person. And this other person, when we confront both of them, now we can solve it. Well, we are going to create a parallel problem, our model, where we're going to make the ratio be the same. We're going to force they have the same amount of cookies at the end. Solve A and B. Now we update our model, but now with number of cookies. Okay, but this is still the ratio. Now what? Well, the ratio, but this is actually, I'm sorry, this is number of cookies itself, right? So 32 cookies minus 12 cookies is 20 cookies, 70 cookies minus 50 cookies, 20 cookies. So we update our model, but now we have to go back to our original problem. How? Well, we just have to undo everything we did. If we multiply this by 4, divide by 4. If we multiply by 5, divide by 5. If we multiply by 6, divide by 6. So once we update this, so we have our answer. Well, this is our problem. Thank you very much for watching one more video. I hope you're enjoying those videos. The idea is to think, is to force our minds to get out of the comfort zone. And if I was able to do this today with you, mission accomplished. Thank you very much. If you enjoyed this video, please give the like. It is very important to me, so YouTube can send this video to other people and the channel can grow. Without likes, this video stays with very short amount of videos. No one is going to see. YouTube is not going to do nothing, and they're going to disappear, and you see, we just kill me. So if he's not asking too much, please give the like. Give the like. It's very, you have no idea how much important it is a like for YouTube videos. And also, if you enjoy my style, please consider subscribing. It's going to be an honor to have you as a subscriber. So see you next time. I hope you enjoy those 30 minutes, and See you later. Bye bye. Have fun and have a wonderful day. Bye bye. And see you next time. Bye bye.